Okay, so now this board is different than all the others. This is the front panel board. It has, the LEDs go in here, and the Raspberry Pi goes over here, and then these transistors here convert the Raspberry Pi voltage to the tube voltage, and vice versa, right? So the Raspberry Pi is 3.3 volts for I/O, and the tubes are, generally 0 to 5 volts, but you can have, you know, even negative voltages a little bit on these pins. So you have to have transistors to convert the voltages to make sure that no out of range voltages get on this Raspberry Pi. So generally, there's a 3.3 volt output out of the Raspberry Pi, and that runs to all the transistors in here that so that it's impossible for them to go out, above that 3.3 volts. Okay, well, unless the transistor, of course, shorted out or something like that. But normally, as long as the transistor is working, the Raspberry Pi won't get an out of voltage condition on it. And then I use transistors here to drive the LEDs. And so that's what this board is. So this is kind of the cheat board. All the cheat stuff is all in one here. You have LEDs and transistors, and of course the big cheat, the Raspberry Pi. But still, you can say, oh, the processor itself is still all tubes. But this is the just transistors for level conversion and to drive the LEDs. Now, of course, with LEDs, the important thing is to get the polarity right. Now, before I do this, I have this old board here, and I drilled holes in the LED, a little hole here on the square peg. There's a round and a square pin, pad. A round pad and a square pad. So I drilled out all the square pads with a bit that was the diameter of the LEDs. So I'm going to put the LEDs in here, not solder them, put this over the top, and tape it down with the tape, and that will hold the LEDs fairly straight when I go solder them in. Now, when I did this, a year and a half ago or whatever, the first time, I had already put these transistors in, so I had to drill these big holes. But since I smartened up a little bit, um, I don't I wouldn't need these holes if I were going to start it all over from the beginning. But I have these holes drilled out for the LEDs on, one of the others, because the minimum order quantity is 5 on circuit boards, so you'll have at least one extra for doing this. So I'm going to set this aside for now and just stuff the LEDs in the way I want them. Now I have orange and red LEDs because those are PDP-8 colors. Don't necessarily need different colored LEDs. You can have any colors you want, really, but I stuck with the red and the orange. And the way I did it was the link starts with the orange, and of course you can do it however you like, and then I just alternate columns for all the octal digits. So it's just a matter of sticking these in here and flaring the leads out, and I'll show putting the tape boards on. And make sure you get of course the anode and cathode right. So the long lead goes on the left. That's the anode that goes to the positive supply voltage. And the way it works is, let's see, make sure I skip 3 because I don't want to put the get my colors mixed up. So there's an octal digit there. You have the link and then 3 bits for the octal digit. And the way this works is there's a resistor that goes to the power supply, right to the 5 volts, and on the left side, and then the right hand of the LED goes down to the transistor that's right there. So that's how you want to keep the anode, the long wire of the LED, on the left side, and then just stick them in and flare them on the bottom. And then when I get all these stuck in here, and there's what, 50 of them or something like that. Now when we get all these in here, we'll try to put that top board on. It's not necessarily going to be easy, but I did it before, so I should be able to do it again. Famous last words, I know. And get all these done here. I don't know any way to abbreviate this. Let's see, so red, orange, red, orange for this last column. Guess I shouldn't leave these here, they'll go flying at some point. Once again, and you can double check that you got the long wire and the short wire when we flip the board over before we tape it together and solder it. Of course, you have until you solder it to get the things in the right way. Long wire on the left, long with L. Alright, so those are the orange ones for the accumulator and the link. Suppose you could checkerboard them. You could make an orange column here now, but yeah, just stick with the way I did it before. This is the memory address register. Again, double check the lead length. Make sure you get the long wire on the left. Last thing you want to do is solder a bunch of these in and have them in the wrong way. Get another one here. Let's see. I guess you can. I guess it's coming out on the video, isn't it? Oh. Get this one in here. There's what, like 50 of these, so not a whole lot. Fortunately, it doesn't take too terribly long. Suppose I could stand the board up a little bit. Be easier now that you see what's going on. See, there's the bottom. I'm just flaring the leads like they were resistors or something. And when I get all these in here, hopefully that top panel will fit on and hold them somewhat straight. Otherwise, I mean, you don't need to, but it just makes it look a little nicer. Otherwise, yeah, some of them will be a little crooked and they won't light up evenly. Alright, now we can do the program counter. Let me just get these in here. This goes by pretty quickly, I guess. There's supposedly a flat edge on these LEDs, but I can't tell which edge is flat. It's supposed to be the cathode, I guess. I just have to tell by the lead length. I can make one a little longer than the other. Let's see. Suppose I could have used bigger LEDs too, but these work. Or even incandescent bulbs, but then you'd have to worry about sockets and all that kind of stuff. So I wanted to use neon bulbs, but and you'd have to have tubes to drive them, and well, you wouldn't need tubes to drive them, of course, but it was just too much design work, and I just didn't want to go through it. Now, here are the states. Okay, so there are three. These are they kind of match up with the regular numeric LEDs, numeric registers. You have three IR bits, so we'll match those up with the same color corresponding to the regular numeric registers. Now there are just two fetch states, so we'll use the same colors here, down here. Again, if you're gonna, you can do it however you like, but that's how I do it. So I'm gonna put fetch here in yellow or orange. Get that going. Yep, the leads are the right length. Check this one here. Get the lead on the right side. Long lead on the left. Alright. And then there are three defer LEDs, so I'll make those red. And three execute LEDs, I'll make those orange. And again, long lead on the left. Three execute states. Some instructions only need one, most of them need two, some need three. Was it just two instructions or something need three? Let's see, TAD, ISC, and TAD, ISC. Let's see exactly. Should get the long lead on the left. TAD, ISC. Anyway, okay. Make sure there's another one. I think there's another one. I just can't think of it. Alright, now, so all the rest are red, hopefully. And the interrupt acknowledge will be red as well. That's a state all by itself. So I got three oranges left. I'll put them aside. Back in the bag so they don't get lost, in case I need them. Like if I got one of these backward, I don't think I did, but it's possible, and I had to yank it and put another one in. Alright, so we have reds for the rest. Get these going. Alright. Now, we can get these in here. Getting long lead on the left. There we go. Get started with it. Now, unfortunately, this board, there's a bunch of different resistor values and stuff for the voltage converters. See, it's not as easy putting this board together as it is any of the others. Bunch of different values, and really the only way to do it is to have the schematic open, the KiCad schematic open, so you can see what the values are as you do it. So it makes it a little bit of a pain compared to the other boards. Again, get the long lead on the left and the anode on the left, right? Cathode on the right. Alright, and get all these in here. So we'll do these bits here. Get the memory address register bits. One more. This doesn't take too long. That's very, very easy. And testing it is the same as with the other boards, except you have to stick the Raspberry Pi in here. And you stick the Raspberry Pi in the Raspberry Pi hole. Shut your pie hole. You stick the Raspberry Pi in the Raspberry Pi hole. You put the paddles on the paddle connectors. And the test program will send signals out the Raspberry Pi and make sure it can read them up here on the bus connectors with the paddles. And vice versa, it'll send signals out to paddles and make sure it can read them all in the Raspberry Pi. I don't think it does anything with the LEDs, but it probably puts random numbers on the LEDs, because I don't get too terribly clever about how to write these test programs. I figure, well, if I can generate random numbers and it works with random numbers, that's good enough, and it's worked out. That tests every combination that needs to be tested, I think, anyway. So I don't bother to get clever with the test programs. I just kind of take a big hammer is the way I look at it with the random number stuff. Anyway, okay, so let's get one more LED. Get the long lead on the left side again. Oh. There we go. Alright. Not too much left here. Get these in here, and then we got the big board placement thing. Put that board on top and try to tape it down without the LEDs going flying. And I guess the LEDs aren't going anywhere. The leads are flared on the bottom. It's just going to be a matter of getting that board to fit on top here. And then we can go through and solder these wires on the bottom. And we'll get this wire in here. Oh yeah, speaking of LEDs, right down there, let's see. That's the HODE computer. I have it running its rolling LED program. Rolling light program. So yeah, you can see those rolling lights going down in the corner. Anyway. It's a lot quieter than the tube computer. Alright. Finish these up here, just a few more. Suppose I could have put the interrupt acknowledge over here and these would have lined up a little nicer, but you know, they're good enough. What the heck, it runs. One more here. Alright, there's the memory address registers done. There's going to be a lot of wires to solder on the back in a minute. I didn't grab my cutters. Alright, let's see. Long wire, short wire. Long wire, short wire. Just a couple more. Long wire, short wire. Alright. Good. Yep, just a couple more. Long wire, short wire. Yeah, I didn't think of this red and orange LED thing until the last minute putting the other one together. So I have a bunch of reds left over from the first one. I thought at the last second, I was like, oh, I could put orange in here. Make it more PDP-8 like. So I have a bunch of reds left over. Alright, just one more after this. Yeah, the light kind of lights up the orange ones, doesn't it? Alright, last one. Long wire on the left. Long wire on the left, good. Alright. That's a mess. I guess it's going to be hard to tell which is long and which is short on the. Now that they're flared. Alright, now the interesting part. See if this will actually fit on here. I did it one time, so. I did it once. And there they go. Well, I think the tops are sort of in there. The rounded tops. Now, oh, MA06 has gone AWOL. Did I put an LED in there? Yes, I did. Maybe I can wiggle it with the bottom wires. Let's see. There's 8, 7, 6. Well, it's gonna have to come up. It must have got bent over. Oh, come off. Oh, see, I pulled one of the leads out. Wow. Ooh. ME06, yeah, it got bent over. Ooh, that's no good, huh? I don't like that. Let's see, we'll just try to get it bent back. Which one came up? That one came up. Flare these leads a little more. Oh, if I can find the right one. Oh, there we go. Yep, that's it. There's one next to it. Alright, now be more careful about MA06. Get this going again. There's MA06. Come on. Oh, it survived. Hope all the rest did. Let's see. Wiggle them a little bit. Wiggle it just a little bit. There. What do we got? We got them all? Yep, okay. So it looks like they're all in there. So now I'll take a bunch of tape. Oh. Tape these edges down. Oh. It's so painful. And this hopefully will make the leads look more or less uniform. Otherwise, yeah, some of them would be off a little bit on the angles and stuff like that. Make sure these are all in still. Yeah, I'll tape this edge down. I'm holding not real firm, but somewhat. I'll get some over here. I don't want it coming apart when I flip it over. I guess those are still all in there, right? Yep. They're all in there. Don't let this come up. No, I can't set it down on all those wires. get some tape on here. Tape. Tape with the tape. Alright, one more. That'll be enough. Alright, they're still all in there. I'll check them all. Make sure they're still in. So when I solder them, alright, so I think it's just a matter of soldering here. I have to grab my cutters. Where do my cutters? Yep, they're way over there. Hang on. Yeah, there's probably nothing special from this point on. It was just a matter of I just wanted to show these LEDs. So I should put these back before they go all over the place. But I'll finish soldering them if anyone wants to see. Oh. Suppose I could check with the ohm meter after I get all the LEDs in. I could check to make sure I put them in the right way. But we'd know when we turn it on, try to use it, wouldn't we? I was careful enough, I think, to get them in the right way. Yeah, with all these wires in the way, it's not going to be easy to solder, but yeah, let's see what we get going here. Not too hard. There are, what, 50 LEDs, I think, plus or minus one. $25-25 split, more or less. For the colors. Yeah. Ooh. Oh, it's very prickly on the fingers. Try and get this in here with all these other leads in the way. That's pretty easy soldering otherwise. Oh, just a matter of getting to them. Yeah, the hardest part of these is there's like 4 different resistor values, and you got the 3904 transistors and the 7000s, you know, the MOSFETs and the bipolars. You got to get those in the right spots. I use the MOSFETs whenever I'm reading from the tubes. So I use MOSFETs for that, because if you try to drive a bipolar off the tube cell, it doesn't work out too well. Those tubes, they only operate like 1 milliamp. And, you know, conducting through the tube is a little under 1 milliamp. It's like 800 microamps or something like that. So there's not much power. So when you go to a transistor circuit, you have to use the MOSFETs. At least that's the way I set it up. That was the easiest way. Easiest thing to do, and keep all the tube circuits the same. Those 6J6s weren't meant for power at all. I think they said you can use 1 watt on them, but you know, I only use 30 milliwatts or something like that. So they're way underutilized as far as power goes. Yeah, this is working. This shouldn't be too much difficulty to get all these in here. Oh, I know. It's wrong. I have the wrong glasses on. Thinking something was funny. Yeah, that's a little better. I can see a little better. I guess I got the light too much in the reflecting. But, well, you can see where I'm soldering here, if you care. Finish these up. Alright, well, that's half of it. And we can finish it up. I should probably play all these videos back at 2x if you even bother looking at them. Get all these done here. Just a few more. I also looked for those vacuum fluorescent displays. All I could find were ones that had lots of digits for, VCRs and stuff like that. That would have been nice to been use something like that. That would have been more tube-like. Because they're sort of low power devices. So they would have worked out with other tube circuits, but couldn't find anything I liked what it looked like. And didn't look very PDP-8 like too. They were kind of greenish blue. And incandescence, take a lot of milliamps. So I ended up doing the transistors and LEDs. Kind of a cop-out, but I wanted to keep it practical for me to do, otherwise it would never get done. Someone was saying, oh, make core memory for it, but that'd be way impractical. Way too many tubes. If you wanted to do that with tubes, and it wouldn't be much point doing it with transistors. I'm going to skip these taped over ones for now and do that when I get the tape off. These would be the state LEDs here. Yeah. Skip that one for now. Do these last three. These are the instruction register bits here. There we go. Alright. I'll just peel these off now. Get these. And this last one. Alright. Get this done. There's the last one. Yeah. Alright, there should be every one of them soldered in. Double check here before I take it apart. Oh yeah, one thing I did on this panel that I did not do on the originals. That made it worthwhile to do another panel. Oh, if I can get the tape off. And I will show you. Oh. Now let's see. Get this tape off. Ooh. Ooh. Hopefully it comes apart. Well, I'll take these top ones off then and then pull it apart. Oh, come on. Let's see if it comes apart. Well, there it goes. Huh. I couldn't have soldered it together. There we go. These are just kind of sticking in there. Alright. Yeah, that looks pretty good. Yeah, that's came out pretty good. Now you might notice one difference between the two panels. Ta-da-ta-da, I thought though I would stick that logo on there. So there's the new panels with the new logo. Now I'm not going to bore you. You know, I did the paddle. I did the paddles to show putting in transistors. And again, you just have to be really careful. Get the right transistors in the right spots and resistors. And there's diodes in here and all kinds of crazy stuff. You know, there'd be Zehners in here with these, wherever you got a MOSFET going into the LEDs. These are the MOSFETs here driving the LEDs because they just take signals right off the tubes. And so there's going to be a little Zener here to protect the MOSFETs because the MOSFETs are only good for plus and minus 20 volts, and it keeps the static off them and all that great stuff. And there's MOSFETs up in here because they take bus signals in that go to the Raspberry Pi. And then I just use the 3904 NPN transistors for signals coming out of the Raspberry Pi going out to the tubes. And so that's about it. So that's all there is to that board that's different than any of the others. So I'm going to leave it at that. And I'll do another video, probably show testing this. I'll put the Raspberry Pi on and put the paddles on and show testing that. And we'll see what happens at that point. All right.